This is a science collision between Crash Course, the Amoeba Sisters, and Bill Nye the Science Guy, brought to you by Professor Neil Kapoor and Rachel Anderson. This episode of Crash Course is Anatomy and Physiology, Muscular System, Neuromuscular Junction, the Sliding Filament Model, and an Anatomy of the Sarcomere. Hi, I'm Bill Nye the Science Guy. Today my friend Hank Green from Crash Course and I will be explaining the steps of neuromuscular junction and how it relates to muscle contraction and relaxation. In a separate video, the Amoeba Sisters will examine the anatomy of the sarcomere. To analyze contraction, we will take a look at an individual muscle fiber. We begin with action potential coming down the axon to touch the voltage gates and opening the calcium channel. The gate, which is now open, allows calcium to rush down, entering the axon and bind to vesicles. The process of contraction begins with the neurotransmitter acetylcholine, or ACH for short, sending a signal from within the fiber. It then goes down the axon. This is you more or less making the decision to move a muscle. Although you don't think about it, you simply do it. The neurons are fired from your brain. The neurotransmitter ACH makes its way through the membrane, which will become depolarized due to positive Na+ ions within. This will take us into the next step, where an action potential will be triggered, resulting in all other membrane also becoming depolarized. Something called a motor unit will respond to the action potential. From here, Hank Green will explain the rest.
There are two different types of motor units. We have larger motor units used for bigger processes like walking, running, or jumping. And we have smaller motor units used for the smaller, more delicate and precise processes like blinking, wiggling your toes. The neurons will trigger the release of calcium. Action potentials travel down via T-tubules releasing calcium. Calcium then binds with the troponin and pulls tropomyosin. Tropomyosin does not allow the myosin to bind with the actin. When tropomyosin is taken out of the picture, the myosin can now move about freely, allowing for muscle contraction. This period is called the latent period. However, only the myosin heads that can bind are those that have converted ATP to ADP and are also holding onto a phosphate. The myosin will bind to the actin, and all previously stored energy from initial release is finally released from the myosin. Remember, structure determines function. The myosin needs to unbind from the actin, so it will now change shape, causing it to release the ADP and phosphate. A new ATP will be attracted to this new structure of the myosin and will now bind to it, allowing for the myosin to detach from the actin. The myosin can then return to its original shape, and the process is repeated when needed. An ADP and phosphate are attracted, calcium binds to troponin, and myosin binds to actin. As this happens, the sarcomere begins to shrink in a way that results in the contraction of the muscle. Of course, it isn't exactly shrinking per se, but it is contracting, thus allowing you to move. When the sarcomere contracts, the thin and thick filaments will slide past one another and they will overlap. This is how the muscles shorten and contract.